Hello, I'm your TA. In this video, I'm going to share you my solution for exercise 12.1 in Howell 8th edition. Let's take a few seconds to read the scenario first. Okay, these two groups are control group and these three groups are experimental group. So I will call these two groups, this ad lib control group as AC and 2 per day control group as TC group, and food deprived group as FD, water deprived group as WD, and food and water deprived group as FWD. Let's review the ANOVA table first. To calculate the ANOVA table, we need group mean. So 90 divided by 5 is 18. This is my group mean. Divided by 5, 8, 24, 8, 12, 11. So we need grand mean. So we add these all numbers and divide by 25, the total number of 14.6. Let's go to ANOVA table. So my null hypothesis is gonna be all group means are equal. And my alternative hypothesis is at least one of the group mean is different from others. So sum of square treatment formula is this one. And I copied group mean and grand mean in the bottom here. So 5 subjects in each group. So 5 times 18 minus 14.6 squared plus 5 times the second group TC group mean is 24, grand mean 14.6 squared plus 5 times third group food deprived group mean is 5 minus grand mean squared 5 times water deprived group as 12 minus 14.6 squared plus 5 times last group mean is 11 minus 14.6 squared, 816. And degrees of freedom is the number of groups minus 1. So 5 minus 1 is 4. And MS treatment is sum of square treatment divided by degrees of freedom of treatment. So 816 divided by 4 is 204. And sum of square error is sum of square total minus sum of square treatment. We need to calculate the sum of square total first. So sum of square total formula is we need to subtract the each subject's score minus grand mean squared, and then we need to sum them up to all subjects across all groups. So we need 18 minus grand mean, 14.6 squared. And second one, 20 minus 14.6 squared. Third one, 21 minus 14.6 squared, up to this last number. So 11 minus 14.6 squared. So if 928. So sum of square error is 928 minus 816, which is 112. And my degrees of freedom of within group is Kn minus 1. So we have 5 groups and there are 5 subjects in each group. So 5 minus 1 is 5 times 4 is 20. So 4 plus 20 is 24. So degrees of freedom of total is 24. And MS error is sum of square error divided by degrees of freedom of error. So 112 divided by 20, which is 5.6. So my F value is mean square treatment divided by mean square error. So my answer is this one, and mean square error is 5.6. If we divide 204 divided by 5.6, my value is 36.4285. And my F critical value is with significance level of 0.05, alpha is 0.05, and my degree of freedom is 4,20. In page 692, we could find the F table. So we need to find F alpha is 0.05 and degree of freedom as 4,20. We need to check the alpha, and 4 and 20. So my critical value is 2.87. So my critical value is 2.87, and my F observed value was 36.4285. So my observed value is here. So after the critical value, that is a rejection area. So we can reject the null hypothesis. We reject the null hypothesis, we need to compare one mean with another mean. So we learn linear contrast. At least one of the group mean is different from others. So to compare one mean with another mean, we are gonna learn linear contrast. Especially, I'm gonna make orthogonal contrast. So my first contrast, I will call contrast A, is comparing control group and experimental group. So my first null hypothesis for the contrast A is the average of the first two group mean, which is mu AC and mu TC, is equal to the average of the three group means. So mu of FD, mu of WD, plus the mu of food and water deprived group. So for doing some little algebra, if I move this part into the left, we can connect them as minus, and then we can make them as equals to 0. That is why we put the minus here and make the equals 0. We are gonna keep equal 0. And then my second contrast gonna be comparing control groups. So I'm gonna comparing group AC versus TC. So my null hypothesis for contrast B is mu of AC equals mu of TC. So we can rewrite as minus mu of TC is equal to 0. And my third contrast gonna be comparing for single deprived treatment group versus double deprived treatment group. So I'm gonna comparing FD, WD versus FWD group. So my null hypothesis for contrast C is average of the first two group, mu of FD plus mu of WD, is equal to mu of FWD. We are gonna keep equal 0 system. So I'm gonna move mu of FWD to the left. So I will connect them with a minus equals 0. And my last contrast D, is comparing single deprived treatment group, which is FD versus WD. So my last null hypothesis for contrast D gonna be mu of FD minus mu of WD is equals to 0. So for convenience of the calculation for the further steps, we are gonna fill out this table. Copy and paste sample mean first for each group. So AC was 18, 24, just in case. 40 divided by 5 was 8, 60 divided by 5 was 12, 55 divided by 5 was 11, and this was 90 divided by 5, and 120 divided by 5 was 24. And this column is sum of coefficient of linear contrast, and this column is the sum of the square of coefficient of linear contrast, and this column is linear contrast. So for my contrast A, the coefficient for the mu AC is 1/2, so I will copy 1/2, and coefficient of mu TC is 1/2, so I will put 1/2 here. And my food deprived coefficient is negative 1/3, negative 1/3. WD coefficient is negative 1/3 because we multiply this way, negative 1/3. Also, food water deprived group coefficient is negative 1/3. So if we add these coefficients of linear contrast, 1/2 plus 1/2 is 1, negative 1/3 plus negative 1/3 plus negative 1/3 is a negative 1. So 1 plus minus 1 is 0. So this is 0. And this one is sum of square of linear contrast coefficient. So to calculate this one, we need to squared linear contrast coefficient, and we need to sum them up. So if we add this one, my answer is 0.8333. So I'm gonna write 0.8333. And then my psi, we call this one as a psi. We need to multiply linear contrast times the group mean. So we need to multiply 18 times 1/2, 12 times 1/2, 8 times negative 1/3, 12 times negative 1/3, 11 times negative 1/3. So for this one, we can rewrite as 18 times half, 24 times 1/2, 8 times negative 1/3, 12 times negative 1/3, plus 11 times negative 1/3. So if we calculate this one, my answer is 10.667. For my second contrast, there is invisible one in front of mu of AC here. So my linear coefficient of mu of AC is 1 here. And 1 is also hidden in front of mu of AC. So, and we have a negative sign here. So -1 is my linear contrast for mu of TC. However, there's no term for FD, WD, and FWD. Those linear coefficients are all 0. So my sum of linear contrast 1 plus -1 is 0. And if I squared it and then add them up, 1 squared is 1 plus -1 squared is 1, which is 2. And to calculate the psi, we need to multiply 18 times 1, 18 times 1, plus 24 times -1, which is -24. And 0 times 8 plus 0 times 12 plus 0 times 11 is all 0. I will not write it. So 18 minus 24 is -6. So I will write highlight as blue, contrast C. So there's no term for AC and TC, so my linear coefficients for those two are 0. And F in front of FD, we have 1/2, so 1/2. And in front of the mu of WD, there is 1/2 is my linear coefficient. However, there is 1 is in front of the mu of FWD. So -1 gonna be my linear contrast coefficient for mu of FWD. So if I add 1/2 plus 1/2 -1 is 0. And if I square them and then add up, which is 1/2 squared plus 1/2 squared plus -1 squared, which is 1.5. And if we multiply 8 times 1/2, 12 times 1/2, and 11 times -1, which is, I will just in case write this one, 4 times 18 plus 0 times 24 plus 1/2 times 8 plus 1/2 times 12, -1 times 11. So if I add them up, which is -1. And for my last contrast, I will highlight it as range. So there's no term for AC, TC, so my linear coefficient is gonna be 0 and 0. And 1 is hidden, so 1. And -1, no term for FWD, so my coefficient is gonna be 0. So if I add them up, so 1 negative minus 1 is 0. And then we square 1 plus -1 squared, which is 2. And my psi for orange is, because 0 times 18 plus 0 times 24 plus 1 times 8 plus -1 times 12 plus 0 times 11. So if we, because these are all 0, 8 minus 12 is -4. So let's solve letter B first. We need to show that linear contrasts are orthogonal. So we need 3 conditions to meet the orthogonal. So first is the sum of the linear coefficients are 0. So we already check in this column. The sum of the coefficients are 0. The second one, this is done. The second one is the sum of the set of coefficients for different contrasts gonna be 0. So we are gonna check second one later. And third one, the number of comparison is equal to k minus 1. Here, k is the number of groups. Because we have 5 groups, 5 minus 1 is 4, and we have 4 contrasts. So we met number 3. So 1 and number 3 is done, and I'm gonna show you how to do number 2. Because AJ and BJ are set of coefficients for different contrast, we need to check all 1, 2, 3, 4, 5, 6 combinations. So AJ is 1/2 times BJ is 1. So 1/2 times 1 for AC plus the second one for TC is 1/2 times -1 plus -1/3 times 0. Fourth one is -1/3 times 0 plus -1/3 times 0. So something times 0 is always 0. We don't need to consider the last 3 terms, and we only consider these first 2 terms. 1/2 minus 1/2 is 0. Okay, and let's calculate the sigma AJ and CJ. We need to consider the green row and yellow row. So 1/2 times 0 and 1/2 times 0 plus negative 1/3 times 1/2, negative 1/3 times plus 1/2, negative 1/3 times negative 1, negative 1/3 times negative 1. So something times 0 is always 0, it's all gone. And this one is a negative 1/6, negative 1/6 plus 1/3, which is 0. So if I calculate all the combination of two coefficients for different contrasts, everything is 0. So we can say the linear contrasts are orthogonal. Let's solve letter A. Analyze the data using the linear contrast. On the right table, highlighted with the gray color, is the regular ANOVA table. So we already completed this ANOVA table in the first part of this video. So I'm gonna show you how to do with the contrast A. Let's recall that contrast A was comparing the control group and treatment group. So we compared these two groups versus food deprived, water deprived, food, water deprived group. So my null hypothesis for contrast A was the average of the mean score of these two groups, mu of AC, mu of TC, is equal to the average mean score of these rest three groups. So mu of FD plus mu of WD plus mu of FWD equals 0. Because we are comparing two groups for the contrast, my degrees of freedom of contrast is always 0. So all my degrees of freedom for the contrast is 1. So here is always 1, regardless of what kind of groups we are gonna comparing. So sum of square psi 1, psi A is n times psi A squared divided by sum of linear coefficient squared. So let's go to the table on the top. This one is psi A, and this one is sum of square of coefficients of linear contrast. So we are gonna copy these two numbers. Let's plug in. So n is 5. And 0.833. So if I calculate it, this is 682.9825. So I'm gonna write 682 sum of square psi A divided by degrees of freedom of psi A. So sum of square psi A is 682.9825, and always degrees of freedom of contrast is 1. So mean square of psi A is the same number. I'm gonna copy this number to the right. And my F observed score for psi A is sum of square psi A divided by m as error. So sum of square side A is 682.9825 divided by mean square error is here. So we need to copy 5.6. This is 121.9616. So I'm gonna write this number in the table, 121.9616. So we need to find the critical value. My critical value for side A is, I will set alpha as 0.05, and degrees of first number of degrees of freedom is degrees of freedom of sum of square side A, so which is 1, because this number, and the next number degrees of freedom is the degrees of freedom of a mean square error. So mean square error degree of freedom is 20, so 20. So if you find the F value in the F table, which is 4.35. I have compelling evidence that combined control group and combined treatment group have different behavior score in learning task. I'm gonna show you how to do for contrast B, C, and D in this video. The contrast B is comparing the AC group versus TC group. So null hypothesis for contrast B was mu of AC minus mu of TC equals 0. DF contrast is always 1, so I wrote the 1 here. And sum of square psi B is n times psi B squared divided by sum of square of linear contrast coefficient. So in the table, this is psi B, and this one is sum of square linear contrast coefficient square. So we are gonna plug in 2 and -6 in the formula. So 5 times -6 squared divided by 2. So this is, so my critical value is 4.35. So after this line, we reject the null hypothesis. And my observed value is 16.0714. This is FCV, this is F observed. F observed value is much larger than F critical value. We reject the null hypothesis. So I have compelling evidence that AC group and TC group have different scores in learning tasks. Let's solve letter C. We need to show that the sums of squares for the contrast sum to sum of square treatment. So we need to show that sum of square treatment is equal to sum of square contrast A, sum of square contrast B, sum of square contrast C, sum of square contrast D. So sum of square contrast A, B, C, D is here. So if we add them up, we have 0.0 3155 difference, but we could say the sum of square treatment is almost the same to the sum of square contrast A, B, C, and D. I'm gonna show you how to do this one with SPSS. Before showing how to do in SPSS, we need adjustment for linear contrast. We need to put the linear contrast in the SPSS, but the sum of the linear contrast coefficient should be 0 in SPSS. But for the linear contrast A, for us, the coefficient for mu of AC is 0.5, which is 1/2, and 1/2 for TC, and negative 1/3 for FD. Negative 1/3 can be written as negative 0.3. And also negative 0.03, negative 0.03 for food and water deprived group. So the sum of these all linear contrast coefficients should be 0 in SPSS, but if I add this one is 1, but if I add the up, this is a negative 1.9. So if I sum them up, this is 0.1. This is not exactly 0. So to make a 0, we need to multiply LCM in both sides. So multiply LCM, which is 6. So we can make 1/2 as 3 mu of AC plus mu of TC, negative 3 times 6 2 mu of FD, mu of WD, mu of FWD is equal to 0. And then my linear coefficient for group AC is 3, TC is 3, FD is negative 2, WD is negative 2, water and food deprived group is negative 2. So if I add up, this is 6, this is a negative 6. So if I sum them up, my sum of linear contrast coefficients are exactly 0. So when we have some linear contrast with a fraction 1/3, something has a more decimal points, we need to make our linear contrast coefficient to the integers. This is SPSS, so go to Analyze. Compare means one-way ANOVA. So we don't need to consider ID number, and group number 1 is for ad lib control. Group 2 is for TC for us. 3 is FW, and group 4 is group water deprived, and group 5 is gonna be water and food deprived group. So we don't need to consider the ID, and grouping variable gonna be factor, triers gonna be dependent variable. And we need to add contrast. So click the polynomial and linear today. So we need to put the coefficient. My first coefficient is 3, 3, negative 2, negative 2, negative 2, as I shown before, right? So 3, 3, add, negative 2, add, negative 2, add, negative 2, add. And then we need to move to the next. We need to input the contrast to B. So click the next. And then we need to put our next contrast, which is 1, add, negative 1, add, and we need to all zeros. So 0, add 0, and 0. Next, my third contrast was 0, 0, 1 half, negative 1. So 0, 0, 0, negative 1 half is negative 0.5. Oh, that is 0.5. So I did a mistake too. So I need to remove and then let's add 0.5 add 0.5 add. Okay, you need to keep checking coefficient total. This one should be 0. And then we need to add 1 at the end. And then, oh, I did a mistake. So remove it and then negative 1 add. So this is a 0 and we can double check 0, 0, 0.5, 0.5 and negative 1. Okay, next. My last contrast is 0, 0, 1 minus 1, 0. So 0, 0 minus plus 1 minus 1 and 0. Continue. And then if I want to test it for post hoc test, I can click the post hoc. And then if I'm interested in SN key and 2 key, just to click whatever you want and then go to continue and OK. Here is the result. This is the result from the SPSS. So we're gonna check our handle calculation is the same as the SPSS result. So between group, we have A16, 4, 2, 4. So this line matches to our first line. And my within group is should match with arrow. So this one also matches to ours. And the total line is also matches to our result. And then let's check the linear contrast, 3 and negative 2, negative 2, negative 2. And for the other one, our sum of the linear contrast was 0, so we didn't modify it. And here is this contrast test. Let's assume that equivariance met. We are gonna see the first part of the table. Since there is a relationship between t and f value, so if we square t, that is the same as our f value. Because we have only t value here, we need to square them to compare to our result. So I compared t squared, which is f. So 121.90 and my result is 121.96. And second contrast, which is blue, matches here. And contrast C matches with yellow. And last contrast matches to my last result. And just for your information, this is post hoc test. So SNK, we could know that food deprived, food water deprived group as the same group, and food water deprived and water deprived group is grouped as the same group, and AC group as itself and TC group as itself. Tukey SAD grouped as treatment group as the same group, and AC group and TC groups are separate.